What I've been working on is a nearby galaxy cluster called the Fornax galaxy cluster. And the data is beautiful. We actually see a lot of cluster galaxies. And what I have been personally analyzing are the global clusters in these galaxies. So we've been using Euclid. It's much sharper than the typical ground-based imaging we've been having of the whole cluster. And due to that sharpness, we can see those global clusters. They appear just like little points. So it's very hard to distinguish them from other point-like things like stars. But with Euclid data, we managed this pretty well. And so now we have found a lot of new globular clusters. And so we study their physical distribution, their light distribution, their magnitudes, and all of these things to understand like whether there's any difference, for example, between small and large galaxies and all these things. And so far this has been fantastic with the new Euclid data. If you look at like Omega Centauri, the biggest global cluster in the Milky Way, you see all the million of stars, right? As individual stars, it's just a big agglomeration of stars. If I put this object very far away, you don't see the individual stars anymore. It looks just like, so it almost looks like a star from very far. It looks like, we call that a point source. But when you look at it, exactly, but when you look at it in detail, you see that it's a bit broader. It has different light distribution than a star or a galaxy. So we're in this area in terms of distance where we can still distinguish it just in terms of shape from like a galaxy, but it becomes harder and harder. And we just proved that actually with the ERO data, that we're still capable to distinguish that in ERO data. So that's the value of space-based data compared to ground-based. In ground-based, all of this size difference smears out due to the seeing being so bad. There's actually many reasons. So global clusters in themselves are very interesting because we really haven't fully understand how they themselves form. So many people study global clusters also with Euclid nearby ones, just the mass in them, the stellar population, all of this, we don't really fully understand them. So that's one thing. But with the very far away global clusters, we have other reasons why we study them on top of that. For example, if I do follow-up and I understand the velocity at which they move, I can use them as traces of like the underlying dark matter in the galaxy because I can measure how fast they move. But to do that, I first need to know where all of them are because there's millions of sources on the sky that could be a global cluster. And with Euclid, I can narrow it down very precisely and then do like what I call kinematics.